Building Blocks, 2025 in Tel Aviv, the future of tech.
Hello everyone, I'm Jonathan Erez, the head of product of Fhenix, and today we're going to talk about how to bring FHE, not FHE, how to bring FHE to the masses. So first, let's understand what is the problems that we are trying to solve at Fhenix. We call it the transparency problem. So blockchains are transparent by their own nature. It means that all the data is public, including the user's personal data. Now, transparency counts to be many times one of the three pillars of blockchain, together with security and decentralization. It comes with a high cost. First of all, why everything, all the data needs to be public? The reason is that that's the way to reach a consensus. We suggest at Fhenix that we will find a way to keep some of the data, the sensitive data, confidential, and still reach a consensus. We'll be able to build and to shift better products and services in the blockchain space. We are trying to do it with utilizing fully homomorphic encryption, or FHE in short. Now, let's start by understanding why privacy matters. So first of all, as we see it, privacy is a fundamental right. It means that in the context of blockchains, it's not enough that users have control on their data, but they also need to be, the personal data needs to be confidential and private, and the user needs to be able to choose with who they want to share it. So by default, it should be private. More specifically, the transparency problem creates several risks. So it enables to target specific addresses, which make them open for several vector attacks like front running and back running. And it's also a blocker from mass adoption of the technology, since big organizations and corporations won't jump into the blockchain water as far as all the data is public and they have no option of keeping their business data confidential. And lastly, we think that if we find a way of implementing privacy-preserving solutions, it will enable to build the next generation of use cases in that space. Now, before we move on, let's understand what privacy means in the context of blockchain. So usually, privacy is divided into two main types, confidentiality and anonymity. The first one, confidentiality, usually we are talking about confidential transactions, which means that all the transaction details are private, but the details, the identities of the sender and the receiver are public. When it comes to anonymity or anonymous transactions, it means that not only the transaction details are private, but also the identities of the sender and the receiver are confidential. In this talk, we are going to discuss the first type of privacy, which means confidentiality. Now, let's explore in a very brief way what are the privacy solutions that exist in that space. So first of all, as you all know, I guess, zero-knowledge proofs is a big name, or ZK in short, which is a protocol that enables to one party to provide proofs for a specific statement without revealing the statement itself. In the context of blockchain, it enables to remove a lot of the overhead of computations from the chain itself and just providing the proofs. So as you can understand, ZKs are great it's a great solution for scalability. But when it comes to privacy, it's quite limited. The reason for that is by default or by design, always the prover has full access to the data. The next one is MPC, or multi-party computations. This is a protocol that enables multiple parties to run mutual operations without sharing with each other the private outputs. In the context of blockchain, it means that you can, for example, run privacy-preserving operations or functions like sharing wallet custody or private keys. It comes with two main downsides. The first one is that it comes with a high price of communication, which makes MPC best for use cases that require small amount of party members. And the second one, because of the first reason, it's also open for collusion risk. The third solution, TEs, or trusted execution environments, enable to run computation within a secure enclave and run the code isolated. it enables to, in the context of blockchain, it enables to deploy confidential smart contracts with confidential operations, which makes TEs very complete solution for blockchains, but it comes with, again, two main downsides. The first one, it requires, by default, to trust the hardware provider, so you can't truly build decentralized system using TEs. And the second one is that the security level of TEs is quite limited. Lastly, we have fully homomorphic encryption, or FHE in short, which enables to run operations and manipulations on encrypted data without the requirement of decrypting it at any point. But again, also for that, there is a significant con, and it is the fact that it comes with high computation overhead, which makes the performance challenging. So now that we understand what are the existing privacy solutions, let's understand why we chose here at Fhenix to work with FHE. So first of all, FHE counts to be the holy grail in cryptography, and the reason for that is the fact that it enables to run manipulations and operations on encrypted data without the need of decrypting the data at any stage during the process, which makes it truly end-to-end encryption solution. And also because the data is not exposed at any point, it comes with extremely high security level. And lastly, the fact that you can run manipulations on the encrypted data means that you can reach a consensus without decrypting the data. Or in other words, with FHE or utilizing FHE, we can solve the transparency problem. So we can build secure and decentralized system that also saves some of the data or keeps some of the data, the sensitive data, confidential. And lastly, FHE is also a developer-friendly since developers can use it or integrate, once they integrate with CoFHE on the library, they can use it within their own smart contract in the same environment. Next, now that we understand why we chose FHE, let's see what is the best way moving forward. So, as I said, we see that transparency problems as something that is not limited to one blockchain, and therefore, if we will build an FHE-based blockchain, it will be a limited solution. Therefore, the solution that we're looking to build should be built as a tool and provide FHE computations as a service. We call this approach confidentiality as a service. And secondly, since it is mutual to all blockchains, it's also need to support multiple chains. And lastly, because we are talking about an innovative technology, we need to take into account the fact that it will be very challenging, like that the adoption will be a challenge. And therefore, we need to build our system and design in a way that will be developers friendly and trying to lower the entry barriers to minimal. Lastly, therefore, we chose to build an FHE coprocessor, which means that users on the host chain can send requests for FHE operations. And then the coprocessor will calculate and run the operations and will send back the results to the users on the host chain. And therefore, will provide the FHE calculations as a service. With that, we hope that we can reach to a broad adoption of the technology. So now that we understand what is the way that we're looking to move forward with, let's understand actually what we're trying to build here at Fhenix. So we call it CoFHE, and CoFHE will be deployed on EVM chains as a first phase, and therefore it will provide confidential computations as a service to Solidity developers on these chains and the applications that are deployed on the chains. Now, on the developer side, developers can use FHE functions within their Solidity smart contract simply by using FHE function for that, where they want to calculate confidential data. On the end user side, I apologize for all of these errors, it's because the format of the presentation. So the end user side, it means that users can send requests for encryption or to encrypt their data. The most common practice is that users will be able to encrypt their ERC20 tokens, and then will receive the confidential version of the tokens, which enables to execute confidential transactions while keeping their token balances private. Lastly, we think that CoFHE will contribute and will opens up a new variety of use cases in the sector of finance. We'll discuss it a bit more in the next slides. But before we dive into the use cases part, let's understand how CoFHE works. So we won't dive too deep into the technical details, but in a high level, CoFHE will enable users on the host chains to submit a request for FHE operation. then the request will be sent to CoFHE. CoFHE then will calculate the operation, and we send back the result to the user on the host chain. Once the user wants to decrypt the data, he needs to submit another request for decryption. CoFHE then will use a component that's called the threshold network to decrypt the data, and will send back the plain text to the user. So as you can understand, CoFHE covers two main flows. The first flow is a request for FHE operations, and the second one is request for decrypting your ciphertext back to its plain text mode. Now for the use case part. Okay, so what can we build with CoFHE, or which use cases CoFHE enables? First of all, with CoFHE, we can create a new standard of ERC tokens. We call it FHE ERC. And the first one that we're going to discuss is FHE ERC 20. So it means that users on the host chains, on the EVM chains, can encrypt their own tokens, and then they will receive FHE ERC 20 tokens, a confidential version of the tokens, which enables to execute confidential transactions and to keep the balances private. The second one is FHE ERC 721, which enables to deploy and mint confidential NFTs, which contain not only public metadata, but also private metadata, which only the owner has access to. The next ones, CoFHE will enable to build more complete and mature voting systems, where the votes are kept private and only the final result is revealed, or to build more complete and mature decentralized identities, or DIDs in short, system where the sensitive data of the identities of the users will be kept confidential. And lastly, we think that with CoFHE, we can enable the next generation of DeFi applications. We call it DeFi 2.0. And basically, DeFi is one of the most established use cases in blockchains, and it provides a lot of free utilities for end users. But the way we see it, the fact that all the data is public, limiting the variety of use cases or the existing use cases that can be built and developed in that space. We will explore it a bit more in the next slide. So, why we think that CoFHE can revolutionize the DeFi space? We'll start with confidential stablecoins. So stablecoins, the stablecoin market, as I guess we all know, is growing from year to year. Last time that I checked, it reached to over $2 billion in token capitalizations. And the reason for that, as I understand it, is the fact that stablecoins provides great solution for the volatile nature of the market. But as long as all the transaction details using the stablecoins and the balances are fully public, it is limiting the use case and utilities that stablecoins can provide. So with confidential stablecoins, you can utilize the nature of stablecoins to build more secure and mature payment system, or to use it for crypto saving, or for real world assets. And these are just a few examples for the utilities that confidential stablecoins can provide. The next one are two of the most popular implementations in the space of DeFi. So with CoFHE, you can build a private AMM, which means that it includes pools of confidential tokens pair that enables to execute confidential swaps or to provide liquidity in a private manner. The next one is lending protocols. So lending protocols that will choose to integrate with CoFHE will be able to build a mechanism of confidential lending and borrowing on their tokens, and with that, to provide more secure systems that will protect the activities of their own users. And lastly, the credit scoring example is an example for a use case that currently is not developed because it's not feasible as long as all the data is public. So credit scoring, as we all know, credit scoring is a big thing, mostly in the US, but we don't see it in the space of DeFi. Main reason for that is that it's not feasible as long as you can keep the credit score confidential. Yes. With CoFHE, you can create and build a credit score platform that analyzes the user's activity on the chain, then generates a score that reflects the behavior of these users. Of course, this score is confidential and is held and kept by the users. And then the end user can choose with who he wants to share it. So for example, the user can go to centralized exchanges or lending protocols to share his credit score to get better rates. So these examples are just a few for many more use cases that we think that CoFHE enables. Lastly, I want to demonstrate and emphasize the fact that it's super easy to integrate with CoFHE and start working with it as a developer. So, as a Solidity developer, the only thing with a single line of code, you can start using CoFHE. And more specifically, you need to import the FHE.sol library to your smart contracts. And then you can basically start using FHE functions when you want to run confidential computations. So as you can understand, you will see that it is a developer's friendly sense. Developers can still use the Solidity contract, use the same dev tools and test environment to deploy and test their applications. Yeah, so I think that's it. I hope that I got you excited till now. If you want to learn more about what we are doing at Fhenix, please visit us at phenix.io. And one last thing before I finish. I want to say that the future of privacy in blockchain is already here, and we'll be super excited to see you joining this venture and trying to build it together with us.
All right. Don't go anywhere. Don't go anywhere. So I guess my first question, I'll ask the first question. Oh, you have a question? Damn. All right, I'm sorry. All right, here we go. Here we go. Yes.
Hi, great presentation. I'm from SingularityNet, and so I work a lot with cloud compute providers a lot of the time in agent frameworks, workspaces, workloads, etc., and hardware providers. One thing you mentioned early on, it was around FHE compared to other use cases. I wanted to ask a question around where do you see FHE and TE coming together? Because there are more solutions coming to market that are not centralized and they have access to GPU-T and ROT-based hardware using H100s and 200s. But do you see a future where FHE works really well with TE, or do you think that two separate markets where they may need to compete with each other?
Yeah. So, as I mentioned, FHE comes with a high price in the computation side, right? So it means that that's the main bottleneck of FHE. Not for all the data that you want to run in a confidential way on chains, you require this high security level that FHE provides. In some of the use cases, TE is much better in the performance side, will be a better solution for this one. So I guess that I can think about a few use cases that you can build layers of privacy, right? That for the most sensitive privacy features or data, you will use FHE for it to encrypt the data, so you'll keep the high level of security with this data or sensitive data. And for the lower parts, when you need to query the data and decrypt it a lot of times and to run the calculation, it's not super sensitive, you can work with TEs to encrypt the data. So this is just one direction that I can think of. But yeah, I guess that in the end, there are a few ways that FHE can combine with TEs.
Follow-up. I wasn't ready for that.
Yeah, so different question now, great answer though, is around the problems we're having with open source models and decentralization, where a lot of open source models that are coming out there might be ablated, tuned in different ways, and we're not too sure if it's poison potentially. So do you think there's a way that FHE can play a role with assisting the decentralized model market and data market to ensure there's no poisoning of data? Because that's a bubble that may burst at some point in the future if I personally believe if we don't solve that early on than later on. But do you see, simple question is, do you see FHE finding a use case to make sure that decentralized open source models are fairly validated, ensuring that it's not poisoned?
Yeah, it's a good one.
Tough being on stage, Jonathan.
Yes, the question is if FHE can contribute to secure, to keep these open sources secure in the... Yeah, so actually we didn't explore this direction yet. So it's hard for me to tell, so I guess that I need to say that at this point I don't know.
Okay, that's okay. Thank you, Jonathan. I'm sorry for the tough questions, but we asked them to be hard on you.
Building blocks, 2025 in Tel Aviv.